Hello and welcome here at BASF booth of K-Fair 2019. It's now 11 a.m. and this is our first live talk of today. With me here is Paul Heiden from Ultimaker and Jeroen Wiggers from 3D Printing Solutions of BASF. Hello, welcome to the both of you.
Thank you.
And together with them, we'll be talking about the partnership they established to bring FFF printing to industrial scale. So first question, obviously, for me is, what's FFF printing?
FFF printing is filament-fused fabrication. So it's the description of a production method, in this case of polymers in a filament form that are melted in the printer and then layer by layer put into an object of your choice. So layer by layer, it's also called additive manufacturing, because it creates a thing by putting layer on layer instead of extractive manufacturing that we did for millennia.
And the partnership you two have is able to tackle challenges we were facing, or why do we need a partnership?
Yeah, obviously it's to tackle challenges we are facing because this new technology, 3D printing from filaments, it opens up a lot of opportunities, but also creates a lot of challenges. And I think we face the mutual challenges because it all started with, let's say, fun printing of puppets and vases with simple, easy to handle materials. But the whole industry, and especially Ultimaker and ourselves, we have put the aim that we want to go industrial. That means industrial materials, industrial processes. And obviously, you are talking about a kind of system then, so the material has to work very closely together with the printer, which is processing the material. So in this respect, we are working very closely together.
And how far would you say are we from having it on an industrial scale?
Well, we made a tremendous step already. It used to take, and we both remember that, about 6 months before you would actually be able to print with a material. And the reason for being able to do that is that you need to tweak all the settings that you need in order to tell the machine how to print a certain object. These settings in the days were perhaps 200. Nowadays we're talking about 500. So it was no longer an option to really ask our customers to create all these settings. And so what we did is we invested heavily as Ultimaker in software that would allow BASF to create exactly the right settings for their material. And as a result, if you download a material profile, so with the settings, you can immediately successfully print with that material instead of the 6 months of trying that was before that. So that has been a massive breakthrough. And we now allow BASF to make printing profiles for materials in about a week instead of the 6 months that we had.
Yeah, and of course the amount of challenges we are facing are tremendous, but I mean, how do you eat an elephant piece by piece? So in this case it's also true. So we work closely together in establishing the right settings for our materials. We develop new materials, and the end goal obviously of both our companies is to be able to develop materials for end applications. So directly in contact with the end customer, the end user who says, okay, I need a part like this. And fortunately, but also unfortunately, you're not able to use existing plastics for 3D printing. So you have to develop new formulations to make them, let's say, suitable and optimal for 3D printing. So, and that's the end goal, application development together with customers. And then, like I said before, you're talking about a system, a printer and the materials. And the challenge there is that we're working with open systems, so it's not a closed system. An end user can use any material on any printer. And that's obviously making things not easier.
Yeah, I guess. And if we're talking industrial scale, we're probably not only talking local or regional, but also global. What challenges do you see with regards to that?
Well, just imagine that when we started with 3D printing, the material didn't matter at all. And then it's only since 2016 that we entered the professional market as Ultimaker, and we immediately noticed that suddenly the choice of material became important. And actually what you see is that there is this, let's say, connection if a part becomes more critical, the choice of material becomes far more critical. And so what we decided to do, many of the 3D printing companies will say, you need to use our material. And I think that's ridiculous. There are about 70,000 different polymers, and there's a good reason for each of them. Otherwise, they would not have been made. It's very difficult and expensive to make it. So what we see now is that we can support globally any material that is provided. Organizations can provide their printing profile. And what we are now doing with BASF, BASF is the leader in the industry, we are the #1 in the 3D printing industry, is together start explaining to companies, look, 3D printing is no longer about easy parts, simple parts. You can really use it in an industrial fashion because we took care of the settings, we make the right materials available, and you can choose exactly the material that you need in order to print the things that you want. And this is a nice example. I mean, what you see here is something of industrial use, and it's no longer there that the starting point is 3D printing. The starting point is the material, we need to have certain properties, and only then they will look into the 3D printer. And that's what we establish now, that if you use an Ultimaker in combination with any BASF material, we'll get it running for you.
And what do we see here?
Pardon?
What do we see here?
You must be able to tell, right?
Yeah, it's the end part of an, well, we say an air duct, but you can see it on the screen as well. It's a carbon reinforced material which is highly heat resisting. So you are able to use it as the end part of, for example, an exhaust for an automotive. So this is also an example of how, let's say, the industrial applications develop, because starting with prototyping, functional prototyping, we take it a step by step further into real functional parts. And this is now really happening, like Paul said. And coming back on your question, global, yes, absolutely global, because if you want to deliver to the industry, you need to make sure that you have support in every country, that you have a consistent quality of products, that your products are available in all the countries. So this is really a big operation where, also cooperation is required. Because, I mean, the situation in the Netherlands or in Germany is not different than in the US, for example.
So we're really on the next stage now. 3D printing was very much experimental in the beginning. Nowadays, we just have professional users, and they expect us to deliver the same service, the same materials, whether it's in Bombay or Chicago, doesn't matter. And so there's a complete new requirement that requires for bigger companies capable of meeting the requirements of enterprises. That's certainly, this whole industry is currently driven by enterprises. They have the material knowledge, they have the CAD knowledge in order to create such things. So it's suddenly on a complete new level where you need to meet enterprise global requirements.
Maybe one last question to the both of you. What's the next steps for Ultimaker and BASF in this partnership?
Probably, before I can answer that, the biggest promise of such parts is that you no longer need to produce them in a mass production. You can make them where you need them. And you just have the software fly through the air and you just produce it where you need it. So you could easily imagine that, for instance, a machine breaks, you need a spare part, you order the spare part, the software flies to a 3D printer next to that machine, for instance, and it's created. Now, what that means is that the machine instruction needs to be perfect. It needs to be German standard. And as a result, what will happen is that particularly in preparing this machine instruction, which you need to do once because it will be used very often, is that jointly we will deeply invest particularly in creating better G-code, as the machine instruction is mentioned, with UltraSim, and we will try to help people to know beforehand that the G-code they create meets the requirements of the part, that the print actually succeeds wherever it is printed. And if there's any step that we need to take now, it's to make sure that the creation of G-code is not taking 50 test prints or 5 test prints, but that it is right at once. And that's what we're jointly looking for now with UltraSim to get that right.
Maybe to add to that is, I think the next step will be mutual application development. So together with hardware or 3D printer manufacturers like Ultimaker, And of course, to really go industrial, what is necessary is that your manufacturing method has repeatability, has accuracy, and has speed.
Yeah.
And these are also 3 challenges which we are working on and which will be overcome in how many years, Paul?
I think you'll be amazed what you will see at the end of 2021.
Yeah. Okay. Okay.
So to many following years to come. Thank you, Paul. Thank you,
It was a
Jeroen.
pleasure.
You're welcome.
Nice having you here.
Yeah, thanks for having us.
Thanks everyone for watching.